Hello everyone! In today's video, we are going to talk about application of factoring. Before we start delving into the different types of questions, we should take a note that unless an equation is provided, it is imperative that you create a let statement to define your variables. This skill is very important. So let's take a look at our first question type, algebra question. So example number 1. The square root of a natural number is decreased by 15. The value is twice the original number. What is the values of the number? So our first steps of this kind of algebra question is to identify the unknown. So you want to know what value in the question is unknown. So we can clearly see that the only unknown number right here is the number that we're looking for. So we can start by saying let x be the number. Then we need to pay attention on the condition right here. The square root of a natural number is decreased by 15. The value is twice the original number. So next step would be to construct our equation. So what will our equation be? What is the equality implied by the condition in the question? So the square root of a natural number is decreased by 15. So this natural number is our x. Then the square of this natural number would just naturally be x squared. Then the question says is decreased by 15. So we just subtract 15 from this x squared. And this value is anteceding the square of the natural number. The square natural number is decreased by 15. And it says it is twice the original number. And the original number is x, so twice the original number would be 2x. So this value would be equal to 2x. So we can just say x squared minus 15 equal to 2x. And then we can just start by solving this equation. Solving the equation. So let's first move everything onto one side. We can get something like this. And then we reorder everything in descending degree order. And then we can factor this quadratic equation by inspection. And we can get something like x plus 3 times x minus 5 equal to 0. And then using zero products law, we can see that we have two possibilities for the solution of this question. So the first possibility would be that x plus 3 is 0. So x is negative 3. And the second possibility is that x minus 5 is 0 and x is 5. So we have two possibilities. However, we need to double check with any precondition in the question. We can see that in the question it says this number is a natural number. So, is negative 3 a natural number? It is not. Is 5 a natural number? Yes, it is. So the final answer to this question would be that the original number is 5. Because x, as we declared at the very beginning of the question, it is the number that we are looking for. So 5 would be the answer. So, based on these 4 general steps, let's take a look at an example. The ones digit of a 2-digit number is 1 less than the tens digit. The sum of the squares of the digit is 85. What is the 2-digit number? So, after reading the question, we can clearly see that this 2-digit number is the result that we're trying to obtain. So any 2-digit number, we can generalize it as something like this. So it has 2 digits. So basically, we have 2 unknowns here. So we can say, let x be the ones digit. Or let's just use b, because it's in our generalization. Let b be the ones digit, and a be the tens digit. After identifying the unknowns, next step would be construct the equation. And a very useful tip is that in the question, whenever you see a is or equal to or something like that, it usually implies a equality. So our first sentence would be from the ones digit of a two-digit number is, which is equal to 1 less than the tens digit. And our second half would be the sum of the squares of the digit is equal to 85. So we basically have 2 equations in this question. So let's start off by constructing those. So the ones digit of the two-digit number, which is b, as we declared at the beginning of the question, is 1 less than the tens digit. The tens digit is a, as we declared, and 1 less than that. So this would be the equation we can obtain from our first condition, first is condition. Second one, the sum of the squares of the digit is 85. So we're looking for the sum of the squares of the digit. So the squares of the digit would be a squared and b squared. And the sum of them would just be a squared plus b squared. And that is 85. So that would be the second equation that we can obtain from this condition right here. So now our third step would be still to try to solve the equation. So since we have a system of equation, we can start off by substituting equation 1 into equation 2. So we can say substitute 1 into 2. So we can have a squared plus, since b is a minus 1, so a minus 1 squared equal to 85. And then we want to expand the bracket, plus a squared minus 2a plus 1 using perfect squared formula. We could do this, and we combine like terms. And then we move this 85 to the left side. So at the end, we can get something like this. And we can extract this 2 out. Minus 42 equal to 0. And it's simply a squared minus a minus 42 equal to 0. And then, similarly, we can still use inspection to factor this thing. So a plus 6, a minus 7 equal to 0. And by zero product law, we can know that we have 2 possibilities. First possibility, a plus 6 equal to 0, a equal to negative 6. And second possibility, a minus 7 equal to 0, a is equal to 7. Next, we can double check with the preconditions. This is AB is a 2-digit number. So if we have any 2-digit number, inherently both of these digits should be non-negative. So A is greater than 0, and B is also greater than or equal to 0, because A, the leading digit, cannot be 0. So let's go back to our 2 possible solutions right here. So we can clearly see that since negative 6 is not greater than 0, so we need to eliminate this possibility. And 7 is okay. So now we can substitute A equal to 7 back into our equation 1 to find B equal to A minus 1 equal to 7 minus 1 equal to 6. And then we can see that since B is the ones digit and A is the tens digit, So our final answer would be 76. This would be our final answer. So this would be our first question type, algebra question, and there are 4 typical steps that we should follow to solve this kind of question. And next type of question that we're going to look at would be dimension question. Let's take a look at an example right here. So rancher has 300 meters of fencing with which to build a rectangular corral. One of the sides is against an existing wall and doesn't require fencing. If the area of the corral is 11,250 meters squared, determine the dimensions of the corral. So, our first intuitive instinct on this question should be to draw a simple diagram based on the descriptions in the question. So let's start off by drawing a simple diagram. What would the diagram be? So we know that we have a existing wall somewhere. So let's draw it over here. So let's pretend this is our existing wall. And this corral is rectangular. So it has 3 sides with one of the sides against the wall. And the area of the corral is 11,250 meters squared. And the fencing, the total length of the fencing is equal to 300 meters, which is basically 3 sides instead of 4 sides, which is a key point in this question, because one of the sides is against the wall. Our second step would still to identify the unknown, because our general goal for application of this kind of questions is to find the unknowns, construct an equation, and solve the equation to find the value of the unknowns, thus answering the question. So what we are looking for in this question is the dimensions of the corral. So as we know that for any rectangle we have a length and a width. So we can simply start off by declaring that let L be the length of the corral and W be the width. Next, our third step, similar to the algebra question, still to construct n or more equations. So, would be a good, what are some equalities implied in this question? So first, we know that the area of this corral is 11,250. So what is the area formula of a rectangle? The area of the rectangle equal to length times width equal to the area. And the second thing is that the total length of this corral, the fencing of the corral, is 300 meters. So we can see that we have 2 widths and 1 length, and the total sum is 300. So these would be the 2 equalities that we can obtain from the implication of the question. And next step would still be to solve the equations that we get from step 3. So let's start off by isolating L in the second equation. So L would be 300 minus 2W. And we have equation 1, equation 2, and we can substitute 2 into 1. And we can get 300 minus 2W times W equal to 11,250. And we expand the bracket out, we would have 300W minus 2W squared equal to 11,250. and we put the 11,250 to the left side as well. So negative 2w squared plus 300w minus 11,250 equal to 0. And let's get rid of the negative 2. So we divide negative 2 on both sides. We would get something like this equal to 0. And then we can still try to solve the question by inspection. And the inspection of this question will be a bit more complicated. So let's take a look. And surprisingly, we can see that this is actually a perfect squared trinomial. So it's actually w minus 75 squared equal to 0. So w minus 75 equal to 0 and w equal to 75. Next, we still try to double check with the preconditions in the question. Do we have any inherent conditions or any explicit conditions stated in the question? So the only inherent condition that we can obtain from the question would be that the dimensions of a rectangle must be non-negative or all positive, and 75 is a positive number, so it is okay. And then we can substitute this back into equation 2 to find length equal to 300 minus 2w, which is 150, equal to 150. So at the end, we can know that the dimension of this rectangle would be 150 meters times 75 meters. This would be our final answer to this dimension question. So the only difference between question type 2, dimension question, and question type number 1, algebra question, is that for algebra question, the equality is usually stated in the question by a is statement. But for dimension question, we often need to draw a diagram to facilitate us to find the equality. And at last, let's take a look at a challenge question. It's a bit more challenging, and it's neither an algebra question nor a dimension question. So let's take a look. When a football is kicked with a vertical speed of 20 meters per second, its height h in meters after t seconds is given by the formula h equal to 20t minus 5t squared. How long after the kick is the football at the height of 15 meters? So first, let's see if we can identify any unknowns here. So the data that we're looking for is the time, but the time is already declared as t in the question. And the height h is also defined. So we do not need to use the let statement to define any more variables because we have all we need. And then let's take a look at any equalities here. So we're looking for the time when the football is at a height of 15. So this shows that h, which is the height, equal to 15 meters. So let's start off by substituting this into this equation right here. So we can clearly see that 15 equal to 20 minus 5t squared. So let's rearrange it a little bit. We can get this. So negative 5t squared plus 5 equal to 0. So 5t squared minus 1 equal to 0. T plus 1, t minus 1, which is the difference of squares, equal to 1. Sorry, this is actually 20t right here, so I couldn't do this. Sorry. So be careful not to copy the question down wrong, or to make any silly mistakes when you're trying to solve the equation. So this is basically 5t squared minus 20t plus 15 equal to 0. We get rid of the negative sign, and we get rid of the common factor 5. So this is something like this. And then we factor using expansion, minus 1, t minus 3 equal to 0. And by zero product law, we know that there are two possibilities. The first possibility is that t minus 1 is 0, so t equal to 1. And our second possibility is that t minus 3 is 0, so t is equal to 3. So now let's double check with any preconditions or implications stated in the question. So the time inherently would always be non-negative. So these two answers would all be fine. So our two answers would be t equal to 1 second or 3 seconds. So now let's just say that this answer is the final answer of the question. But let's take a look at why. Let's simulate the process of the kicking of a football. So a football is right here. This is the ground. And we are trying to kick it high. So a person right here, and he's trying to kick it. So its trajectory would be something like this. And at a height, so let's say this is the height. At a height of 15 meters, let's say this is height meter, it would actually intersect the trajectory of the football at 2 points. One right here and one at here. Which means that at 2 specific time points, the ball will reach a height of 15 meters, which proved that our two possible answers is correct. So there are two possibilities, one at 1 second and one at 3 seconds. So this would be a question that needs our thorough understanding of this how to